Hi, this is Pete Singer with Solid State Technology. I'm talking to you from the ConFab, and I'm here with Ravi from Digital Specialty Chemicals, and they have some pretty interesting news in that they just have some new funding from Intel. Could you tell me a little more about this news from that you have an investment from Intel Capital?
We started talking to Intel. When did we start talking to Intel?
About summer of last year.
Summer last year? Yeah, summer of last year. And pretty well, it took us a little bit of time, and we closed the deal March 31st.
Correct.
Is when we closed the deal. And they become an equity partner in DSC.
Now, can you tell me, Ravi Laxman, by the way, can you tell me a little bit about the applications that you're focused on in the semiconductor industry?
Digital Specialty Chemicals is a precursor manufacturer over last couple of decades now. We have transitioned from few elements which are on the periodic table to more than 40 elements, making organometallic air-sensitive chemistries, which are used both in the front end and also the back end. As we transition from, say, 14 nanometers to below 14 nanometers, it becomes very, very important for precursors to be of high purity, and we control the manufacturing processes and try to understand the chemistry well ahead of them being implemented into the industry. So this is where collaboration with strategic partners and understanding where the chemistry ends up and what other needs are helps Digital quite a bit in trying to manufacture these chemistries for the semiconductor industry.
Could you comment a little bit about on the specific films? I know they're CVD, ALD, but what kind of films are you depositing?
Traditionally, we actually started manufacturing more into the memory devices, and we actually transitioned back into more into logic materials. These are actually started off with CVD chemistries. As the progression went towards 14 nanometers, now they're more into atomic layer deposition. So we actually work now with chemistries like cobalt, which are used for liners, tantalum nitrides for barriers, for copper integration. In the front end, we also work at other gate materials, high K materials specifically. In the memory devices, we work on higher K dielectric materials.
Could you comment a little bit about on your customers? How would they come and work with you? Any recommendations there?
Our customers are worldwide, and we actually support the end users through many intermediary large corporations which have a very wide bandwidth in supporting fabs worldwide. So our customers vary from gas companies, which are major corporations, all the way to distributions in Korea, in Taiwan, and also in Japan. Our majority of the focus in these materials is actually focused more in the North American continent, but definitely our materials are used worldwide.
Okay, very good. Well, that's very informative. Anything else that you'd care to add?
As we progress more towards less than 40 nanometer technology, we see there is an emergence of more material requirements, especially through the different transition metals in the periodic table, going also into the 3.5 industry. So we actually support not only the semiconductor industry, but we're also working towards supporting emerging technologies such as LEDs, battery technology, and other MEM devices where many of these precursors are required. One of the new things which we have started working on is more on the silicon part, as the double patterning and quadruple patterning, if it happens, it comes to light. We are more focused on silicon chemistries which can be easily etched and made into use in the patterning technology. For example, because of the EUV being delayed, it's actually very, very beneficial for companies like Digital, where we can contribute on silicon chemistries, more on silicon nitride, and also on the oxide part.
You know, Ravi, there's a lot of changes going on in the semiconductor industry toward more complex device structures, FinFETs, 3D NAND devices that require, better step coverage. And there's the famous saying, "Let no element on the periodic table go unused." That must fit well with your plans.
The technology and the growth of our company is really not focused on deposition of the materials in-house, but we collaborate with our partners in doing the deposition part. What we actually try to bring to the table is to evaluate at a very, very preliminary phase, mostly in the R&D phase, how these molecules can be scaled up from a gram molecule into multi-metric tons so that they are competitive and their cost not forbidden. so that we could actually get these materials to the end users. So our partners are counting on us in making sure that we can manufacture these chemistries into full-scale production, especially when Ravi says into the high purity grade electronic requirement, and to make sure that there is no impurities which are going to be carried through the technology nodes into less than 40 nanometers.
Our goal, like we're building a brand new R&D facility right now in Toronto. And that's design is based on how can we get a sample to our clients in less than 6 weeks. That's the goal. Right? That's the design. I mean, you know what? It might end up being, you know, we might fail the first 2-3 times, but absolute goal in our company is to put everything else required in the company to deliver those material in less than 6 weeks. Let them test it out. They'll fail, but they'll understand more, and then they could give us the feedback how to redesign the next chemical and what they want to look for. And that's important for us, because our second goal in less than 6 is actually to be able to deliver kilogram quantities in less than 12 weeks on top of that. Right? And the ultimate goal for us, if the product goes commercial, we promise a +10 scenario. What we mean by +10 scenario, that we will actually reproduce 10 batches in the quality, right, in the right yield, right? And it's critical for us. It's absolutely critical. So it's reproducible.
Very good. Well, thank you very much. I appreciate your time.